had a student ask me to work on number 10, so they weren't specific about which one, so I decided to choose A and C, and you guys can do D and B on your own, B and D. So the first one, they're asking us to simplify, and basically what that means is we have to get rid of the radical on the bottom of the equation. Since this one is binomial, we're going to have to be a little bit complicated about that. So what we do is we recognize that the difference of perfect squares pattern is going to help us out here, because we can multiply any roots by themselves and the middle terms will disappear. So we always set this up by using the same numbers but reversing the sign. And since it's a fraction, I have to do the same thing to the top that I do to the bottom, so I'm going to multiply the top by the same thing. So to set this up, we divide top and bottom spaces, and I could make brackets around here if I wanted to make this look more like we're used to seeing it. And then I'm just going to go, okay, well, negative root 5 times root 7 and negative root 5 times 3 to give me the top part here. So I can go negative root 5, it's going to give me a negative. 5 times 7 is 35, so just negative root 35. And then negative root 5 times 3 is still going to be a negative, and I just put the 3 on the outside and the root 5 there, because the radical and the coefficient don't really mix. Now I look at the bottom part, and I'm going to need to do some FOIL. So my first terms are going to be root 7 times root 7, and since I have, this is just root 7 squared, any root that gets squared is just the number, those two cancel out, or you could make it root 49 and then solve that and it becomes 7. But the fancy trick is just to do that. So I'm just going to have a 7 there. And running out of fancy colors here, so I might have to repeat some. Over here I've got, for my outside, root 7 times 3, so again that's just, it's a positive. 3 root 7, whoops, root 7 there. And first and outside are done, so inside, negative 3 root 7. So then we can see that our positive 3 root 7 and our negative 3 root 7 are going to cancel out and just not bother us anymore. Now, for our last one, we've got negative 3 times 3, so that's a negative 9. Now I can get rid of all my colors, go back to black. I've got the top cannot be simplified because there's nothing there that, even though 35 is a big number, it doesn't have any factors that are perfect squares, so it's just going to stay at root 35. And then on the bottom I have 7 and negative 9, so I just get a negative 2. Now you'll see here that everything is negative, and when that happens in your book book will just factor out a negative from everything. It's like dividing by -1. So our final answer is just going to get rid of those, and we're going to be left with root 35 plus 3 root 5 over 2. Moving on to C. This one, you can see, has a big number under a radical. So the first thing that I'm going to do is look for factors that have a perfect square. What are the factors of 32? Well, 4 times 8 is a good one. Even better though, sometimes you might miss a little one if you do this. So we could just run in the space here. I can go 32 and just run a factor tree. 2 and 16, 2 and, oh wait, 16 is a perfect square, so I don't really have to break that down any further. If I wanted to break it down further, it would just look, whoops, that's a 4, like this, and then I would go, oh, I've got 2 sets of 4 there, so those ones can come out. Either way, the square root of 16 is 4, So this is going to become 4 root 2. Because I've got, either way you do it, I've got a 4 on the outside that gets solved out, and a 2 that gets left under there. So root 32 becomes 4 root 2. I would check my equations before even starting a question, just to see if there's anything that can be simplified, because you really want to simplify before you multiply, or the numbers are going to get crazy big. All right, once we've got that set up, then we can just do the same thing we did over here, and multiply by root 32 minus 3 root 2, and of course, because we changed root 32, we're going to make it, actually let's just rewrite this whole thing. So down here we're going to write 5 root 8 minus 3 root 2 all over, and I'm going to change this now to 4 root 2 plus 3 root 2. Oh wait, what's 4 root 2 plus 3 root 2? Changes again. I've got 5 root 8 minus 3 root 2. I'm just going to put these underlined now because they're the same thing, so I can just go 7 root 2. So now I'm just going to rewrite my equation again, but that's okay because even though it was a little more work then, it's going to be a little less work at this point, because I'm just going to look at this again and ask myself, is there anything that can be simplified? Because even when the numbers are small, they can still have a factor that's a perfect square. And you're going, oh yeah, 8 is 4 times 2, and 4, the square root of 4 is 2. So that means that root 8 actually equals 2 root 2. So now I have 5 times 2, well, let's do it this way. What's the best way to write this? Well, let's just do it this way. 5 times 2 root 2 minus 3 root 2 all over 7 root 2. And so 5 times 2 becomes 10. 10 minus 3 gives me 7. So I'm going to go 10 and minus 3. And I'll write this in blue. 7 root 2 over 7 root 2. And you guys are pretty sharp. You're looking at that going, I know that any number over itself just equals 1. So this whole crazy rigmarole with all the little stuff hidden in it actually just turns out to be 1. Have fun with B and D.